Welcome, this is the IM2 video lecture on solving a trinomial when a is not equal to 1. In particular, we're going to be using the GCF, which is called the greatest common factor. The learning target is for you to understand how to solve a trinomial using the greatest common factor. Your 3 success criteria that you should be able to do by the end of the lesson. 1. You should be able to find the GCF of a trinomial. 2. You should be able to factor using the diamond method. And 3. You should be able to solve for that trinomial. Let's review a core concept of solving a quadratic equation. Here, it says to factor the polynomial out completely, 15x cubed plus 10x squared. Step 1 is to find the greatest common factor. The greatest common factor can be when we expand out each term. 15x cubed was expanded out to 5 times 3 times x times x times x. And 10x squared was expanded out to 5 times 2 times x times x. What I did is I circled the like terms, and I saw that the greatest common factor here was what I circled, which is 5x squared. What I underlined is what is left. So 3x was left over from the 15x cubed, and 2 was left from the 10x squared once we pull out the greatest common factor. So you can write in factor form 5x squared, which is the GCF, parentheses, what is left over. 3x was left over from the 15x cubed, plus 2, that 2 was left over from the 10x squared. This would be the factored form. This is when we extract that GCF. Now we're going to factor in solving the quadratic equation, and here we have 10 squared plus 10x plus 26 is equal to x plus 6. Step 0 was to always put this equation in standard form, so we're going to minus the x to both sides and minus 6 to both sides. That's what you get in standard form. Here you can find the a, b, and c. A equals to 1, b equals to 9, c equals to 20. Use the diamond method. You saw the two factors here that multiply to make 20, that adds to 9, was 5 and 4. So the factors here was x plus 4 and x plus 5. These are the two things that you should already know prior going to this video. So we can also set those factors equal to 0 and solve. So here you have x is equal to negative 4 and x equals to negative 5 for your solutions. So you should have this already. Now, there's something that you should notice and something that you should wonder that come from these. Notice that all these methods, have something particular about that polynomial. Let's take a look. So, number 1, on the left-hand side, it's x squared plus 5x plus 4. On the right-hand side, you have 2x squared plus 10x plus 8. What do you notice and what do you wonder about these two polynomials? On the left-hand side, you can just find a, b, and c normally. A is equals to 1, b equals to 5, and c equals to 4. Here, you could factor normally using the diamond method that we learned right here, which is the diamond method. But on the right-hand side, you can find a, b, and c. A was 2, b was 10, and c was 8. Notice that there is a problem here. A is not equal to 1. Therefore, we cannot use the diamond method. But there is something you can do to get this into this. Notice the number 2, 10, and 8 have something in common. What they have in common is this word, common factor. 2, 10, and 8 have a common factor. We're going to look for the greatest one of those. So this leads us to our core concept, the greatest common factor trinomial. So this was what we have in our last problem, 2x squared plus 10x plus 8. Put the equation in standard form first of all. It's already in standard form. So let's check for the greatest common factor, which is the GCF. The greatest common factor, 2x squared can be expanded, 10x can be expanded, and 8 can be expanded. 2x squared was expanded to 2 times x times x. 10x was expanded to 2 times 5 times x. And 8 was expanded to 2 times 2 times 2. Let's circle our like terms, which is just a pair of, those 2's. And so our GCF here was 2. So those values have something in common. And what they have in common is the number 2, which is the greatest common factor. Let's underline what was left. So x and x, so an x squared was left. Once you pull out the factor of 2, 5x was left from the 10x, and a 4 was left from the 8. Now, when we pull it out, it becomes the GCF parentheses what is left. So 2 was pulled out, which is the greatest common factor, parentheses, x squared plus 5x plus 4. Notice that the inside now is a very good polynomial because we can actually factor it. This is considered to be the new standard form. This is when we pull out the greatest common factor. All right, step 1 is to find the a, b, and c. So a is equal to 1, b equals to 5, c equals to 4. In that process, we can now draw and fill in the values for the diamond method. B equals to 5 and c equals to 4. We ask ourselves, what are the two numbers that multiply to make the number 4 that adds to make the number 5? So those numbers are 1 and 4. We can check here that 1 times 4 is 4, which checks out, and 1 plus 4 is equal to 5, so that checks out. So in factor form, we can write x plus 1 and x plus 4. But notice that the GCF here gets carried over. Right? So that's the only difference in the terms of the factored form. But the solutions are basically the same. You're going to set the factors equal to 0 and solve. So x plus 1 set equal to 0, and x plus 4 was equal to 0. Subtract 1 to both sides, you get x is equal to 1 as the first solution. Subtract 4 to the other side, you get x equals to negative 4 as the second solution. There you go. This is how the core concept of the factoring using the greatest common factor works. Notice this is not new, it's just a combination of the two skills that you should already have. Learning how to factor using the GCF, as well as factoring using the diamond method. Let's go over an example problem here. You're going to find, you're going to factor using the greatest common factor. Step 0 is to always make sure you have the equation in standard form, which it is. Now you are going to check for the greatest common factor, the GCF. So expand it out. You're going to expand 3x cubed, 9x squared, and 30x. 3x cubed is expanded to 3 times x times x times x. 9x squared is expanded to 3 times x times x. 30x is expanded to 3 times 2 times 5 times x. These 3 are in common, and these x's are in common. So the greatest common factor here would be 3x. Let's underline what numbers they have left. X times x, which is just 2x x squared, which is left. 3 times x is 3x, which is left, and 2 times 5, which is just 10. So 10 was left. Now, the GCF that we pull out was the 3x. What was left on the inside is your x squared plus 3x minus 10. All right, like before, that is going to be your new standard form, and that new standard form is what you're going to get, what you're going to factor the diamond method based on. All right, step 1. For the diamond method, find your a, b, and c. A was 1, b equals to 3, and c equals to negative 10. Notice a is equal to 1 here after we pull out the GCF. The a has to be 1 for us to factor using the diamond method. Let's draw and fill in the values for that diamond. B is 3 and c equals to negative 10. We ask ourselves, what are the two numbers that multiply to make negative 10? That adds to 3. Okay. We can look, I think the numbers 2 and 5 work here. So we have the number 5 times negative 2. That gets us negative 10. So that works. 5 plus negative 2. That gets us 3. So that works. So our two factors are 5 and negative 2. In factored form, you get x plus 5 and x minus 2. But remember, you also need the GCF, which was on the outside. So it's 3x parentheses x plus 5 parentheses x minus 2. To find the solutions, you just set the factors equal to 0. Okay, so x plus 5 equals to 0 and x minus 2 equals to 0. Subtract 5 to both sides, you get x is equal to negative 5 as the first solution. Add 2 to both sides, you get x is equal to 2 as the solution. All right. So there you go. Those are your core concept as well as an example problem that explains to you how you factor using the greatest common factor for the trinomials.